All right, the next property of exponents that we're going to explore is called the quotient of powers property. Now, the product of powers property dealt with multiplication because that's what a product is. A quotient is dealing with division. So let's use our 2's again. Let's take 2 to the 5th. Let's put that over 2 to the 3rd. And we'll write that out in expanded form. So we're just going to write out what this really means. 2 to the 5th is just 2 times 2 times 2 times 2 times 2. Okay? And then we're going to put that over 2 to the 3rd, which is just 2 times 2 times 2. Now, we know that some of these 2's will cancel each other out. So this 2 on top will cancel with this 2 on the bottom. These 2's will cancel, and these 2's will cancel. And it's important to understand how they cancel. They cancel each other out because 2 over 2 is just 1, and anything times 1 is itself, so those aren't really needed. So I'm going to replace these with 1 so you can see exactly what's happening here. 2 over 2 is just 1 over 1, so those become 1's. And 2 over 2 is 1 over 1, so those become 1's. So what are we left with here? We're left with on top 1 times 1 times 1 times 2 times 2, so we can write the numerator as just 2 squared. And we can write the denominator as just 1 times 1 times 1 is just 1. So our answer is 2 squared. We've simplified this fraction. 2 to the 5th over 2 to the 3rd is just 2 squared because 3 of these 2's in the denominator matched up with 3 2's in the numerator, and they canceled each other out, leaving 2 2's on the top, which is why we're left with 2 squared over 1. Now let's use some variables and see what we get then. All right, let's do x to the let's do x to the 4th over x to the 3rd. What are we going to get? So that's just x times x times x times x. And then in the denominator, we're going to have x times x times x. And again, same relationship. These x's cancel, those x's cancel, these x's cancel, and we're left with an x in the numerator and just a 1 in the denominator, which can be simplified as just x. Or in this case, x to the 1. Let's put a 1 there so we can start to see a pattern. So what pattern is emerging here? Well, if we have 2 to the 5th over 2 to the 3rd, and 3 of these 2's in the denominator are going to match up with 3 of the 2's in the numerator, then we're just going to be left with the difference of the two exponents. So 2 to the 2 is just 2 to the 5 minus 3. Over here, x to the 4th over x to the 3rd is going to be x to the 4 minus 3. That's going to be x to the 1. So we can extrapolate a rule here. A to the, I need to write a fraction, a to the m, or a to the n, over a to the m equals the difference a to the n minus m. So you take the difference of the two exponents. And that is our quotient of powers property. Okay, using the quotient of powers property we just discussed, I'd like you to try and simplify these three expressions. So pause the video now. All right, let's see how you did. So in this first expression, this is a straightforward application of the property. So we've got x to the 9th over x to the 6th, which is just x to the difference 9 minus 6, which is x to the 3rd. And remember why this works. 6 x's in the denominator are going to match up with 6 x's in the numerator, leaving 3 x's in the numerator and just a 1 in the denominator. So x to the 3rd power over 1 is just x to the 3, or x cubed. The second expression I'm going to break down step by step. You don't have to do this once you understand how it's done, but it's helpful to see how this expression is simplified step by step. So the first thing I'm going to do is I'm going to rewrite this big fraction as the product of three smaller, simpler fractions. So 10 over 2 times x to the 8th over x to the 5th times y to the 10th over y to the 8th. And I can do this using the multiplication property of fractions, since if you multiply all of the numerators in these three fractions, you're going to end up with what you started with, 10x to the 8th, y to the 10th, and the same thing's going to happen if you multiply across the denominators. You're going to end up with 2x to the 5th, y to the 8th. So this is one possible arrangement that would, whose product would end up with what we started with. So now we can take these three very simple fractions and start simplifying them. Well, we know that 10 over 2 is just going to be 5. That's going to be 5 times x to the 8th over x to the 5th is x to the 8 minus 5, which is just x cubed. And y to the 10th over y to the 8th is y to the 10 minus 8, or y squared. So our answer, written simply, is just 5x cubed y squared. Now, this approach is really going to help us in expression number 3. Again, I'm going to split it up into three fractions. You don't have to. Eventually, you'll just be able to see what to do. You'll be able to do this in your head. But I'm going to split it up step by step so you understand what's going on step by step. So we've got 5 over 15 times x to the 12th over x to the 8th times y to the 15th over y to the 10th. Now, this first fraction simplifies to 1 over 3, since 5 and 15 are both divisible by 5. 5 divided by 5 is 1, and 15 divided by 5 is 3. So that's 1/3 times x to the 12th over x to the 8th is x to the 12 minus 8, so that's just going to be x to the 4th. And our next term is going to be y to the 15th over y to the 10th, which is y to the 15 minus 10, which is y to the 5th. Now, how do we multiply x to the 4th times times y to the 5th times 1/3? Well, if we think of these two terms as fractions, then all we have to do is multiply straight across. So we're left with x to the 4th, y to the 5th in the numerator over 3. And here's our answer right here. And if you see, this really does make sense. If we start with 5 over 15, we're going to be left with 1 in the numerator and 3 in the denominator. And that 3 in the denominator really never goes away, even though x to the 8th and y to the 10th are canceled out. So we're only left with terms in the numerator. We still have to remember about that 3 in the denominator, which is why breaking this problem down into 3 different fractions helps you see that that 3 in the denominator never goes away.